Hello, I'm going to talk about control unit. Control unit in this control signal, control word, we have control registers, control cycles, control unit implementation, hardware control, control program, microprogram control. In these, we have horizontal and vertical. What is control unit? Control unit is a component of a computer central processing unit that perform two tasks. The cause is the processor to step through a series of micro operation in proper sequence based on program being executed. It generates the control signals that cause each micro operation to be executed. This is a block diagram of control unit. We have flags, some inputs and clocks in here, instruction register. We have outputs, control signals within CPU, control signals to control bus, control signals group of bits used to opening and closing of logical gates, resulting in the transfer of data to and from the register and the operation of ALU. The control word. The combination of bits which each bit represent one control line. Each micro operation represented by the different patterns of ones and zeros in control word. We have control signals. We have inputs in clock, the electronic device in the computer that is a steady high frequency signal that synchronize all the internal components. Instruction register of code and addressing mode of the current instruction are used to determine within a micro operation to perform during execution cycle. Flags, state of processor, outcome of previous ALU operation. From control bus, portion of the system bus. Outputs we have within CPU cause data movement between registers and a active specific ALU function via control bus to memory and to IO modules. Control register utilize control cycle. We have PC program counter or address of next instruction to be fetched. MAR memory address register connected to address bus. Specified address for read or write of or to memory. MBR memory buffer register connect to data bus hold data to write or last data read. Instruction register IR holds last instruction fetched. This is a diagram execution, how execution perform. Fetch sequence. Address of next instruction is in program counter. Address is placed on register address bus. Control unit use issue read command. Result appear on data bus. Data from data bus copied to MBR memory buffer register and program counter incremented by 1. Data moved from MBR to instruction register. MBR is now free for further data fetches. This is fetch cycle. In T1 cycle, program counter to MAR memory, memory to MBR, and program counter increment. And T3 MBR to IR. This is same as previous one. Rules for clock cycle grouping. Proper sequence must be followed. PC to MBR must precede memory to MBR. Conflict must be avoided. Must not read and write same register at the same time. Also involves addition use of ALU may need additional micro operation. Indirect cycle. In T1 cycle, address register MBR, memory to MBR, MBR to IR. Interrupt cycle. Uh, T1 cycle program counter to MBR, saved address to MAR, routine address to program counter, and MBR to memory. This is a add executive cycle of add operation. Instruction register to MAR and memory in T2 cycle, memory to MBR and T3 cycle MBR plus R1 and that store in R1. Control unit implementation. A wide variety of technique have been used. Most of these fall in two categories: hardware control unit and microprogram control unit. In hardware control unit is essentially a state machine circuit. It is input logic signal are transferred into a set of output logic signals, which are the control signals. This is a diagram of hardware control unit. We have operation code that decoder and some adder for each decoder D1, D2 and outputs and step generator and main circuit and some output control signals. This is a decoder table for 4 inputs and 16 outputs. This is a data path and control signal diagram. In fetch program counter to MAR, active control C2 and for T2, memory to MBR and program counter increment. This will generate for indirect and interrupt, so on. This is the example. Logic in a microprogram control unit is specified by a microprogram. A microprogram is a firmware consists of a sequence of instruction in microprogramming language. Instructions specify a set of micro operations. This is a diagram flowchart. This is so how microprogram control works. We have control buffer register, control address register, sequence logics, and control memory. This is also describe how micro programming control use. We have organizational fetch cycle routine, indirect cycle routine, interrupt cycle routine, execute cycle routine, and we have add routine, and so on and so forth. What is the difference between hardware and microprogram? Hardware uses logic gates and other digital circuit. Micro program uses microprogramming language. As a name implies, it is a hardware control unit. As a name implies, it is a software control unit. The decoder and sequencing logic units are very complex piece of logic. The decoder and sequencing are very simple piece of logic. In hardware, difficult to design, test, and implement compared to program microprogram control unit. It is very easy to test, design, and implement compared to hardware control unit. Inflexible to modify and flexible, we can modify this micro program control unit. Expensive and high error to implement hardware, uh, cheaper and less error to implement in microprogram, used in RISC processor and used in CISC processor, faster than microprogram control unit and slower than micro slower than the hardware. And in micro instruction control for the add instruction, this is a micro which show how add instruction perform. Microprogram control, we have horizontal and vertical micro code. Horizontal microcode, each control signal is represented by the bit in the micro instruction. Fewer control stores words of more bits per word. In vertical microcode, a set of true control signal is represented by shorter code, more compact than horizontal micro instruction, smaller additional amount of logic and time delay than horizontal micro instruction. This is how horizontal micro instruction perform, and this is how vertical micro instruction perform. This is a control field in horizontal, and this is a control field vertical. This is for 00000. We have register and we register to MDR. We have for 000001. We have MDR to register and so forth. This is how horizontal micro instruction works. Format. This is the format. In vertical micro instruction, first source we have 00 destination and operation, which operation we have to perform. For 00 no operation, 001 PC to ABUS, and destination RB bus to accumulator, and operation we have ALU add, and we can perform this type of operation with this pattern. Also we have this example. uh, Difference between horizontal and vertical code. Horizontal we have longer word, and other side we have shorter word. Little encoding to of control information, more encoding of control information. In horizontal, micro data hardware path simpler, and vertical micro data hardware path more complicated. Example of horizontal Power PCs employ horizontal code. For example, for vertical, we have older IBM mainframe used in IBM mainframe used in horizontal big control memory ROM word length and smaller word length, less complex, less complicated to program, more flexible, more complex, more complicated, and less flexible. Horizontal, more easy to modify. Vertical, on the other hand, difficult to modify. Horizontal is faster compared to vertical, and vertical is slower compared to horizontal. Thank you so much.